Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the example number 1 for the Boolean function simplification using K-map for a POS expression. So here we are using a 3-variable K-map. So in the previous lecture, we had discussed the different reduction rules for POS using K-map. Those rules include pair reduction, chord, octet reduction, map rolling reduction, overlapping group and redundant group. And here in this lecture, we are discussing an example for how to reduce a POS using a K-map solution. So let us consider our example. Our first example is simplify the Boolean function f of x, y, z is equal to pi of 0367 using a 3-variable K-map. So as in the SOPs, we had used the symbol sigma of a function, but in the case of a POS, we are using the symbol pi. So the function is f of x, y, z is equal to pi of 0367. If we are approaching with a question with a sigma 0367, we should use the SOP K-map, and if we are dealing with pi of 0367, we should use a POS K-map. So here in this case, we can see 3 different variables, therefore we should use 2 raised to 3 cell K-map, that is 8 cell K-map. And in this given 8 cell K-map, the rows represents the x variable and the column represents the y z variable. So in the POS expressions, if a function is given, then we should mark those max terms with the value 0 in the K-map. That is, since the function is given as pi of 0367, we should mark the value 0 in the cells 0, 3, 6 and 7. So we are marking the value 0 in the cells M0, M3, M7, M6. Next, what we have to do is rest of the cells are marked with the value 1. And after all this, we can start our reduction, or we can apply our reduction rule. Firstly, we are applying pair reduction in this K-map. So we are pairing the cells 3 and 7 with a blue marking. So first pair is cell 3 and cell 7, that is M3, M7. Secondly, we are pairing the cells 7 and 6, that is M7 and M6 are paired. So this pair is represented in a red representation, and we can see the cell 0, and here the cell 0 cannot be paired with any of its neighboring cells. So for the cell 0, there is no reduction and it is marked in yellow color. Now what we have to do is minimize these given sets. So firstly, if we are considering the first pair, the first pair lies in the first and second row, and it lies in the third column. So for reduction, we should consider only the variable which is unchanged. If we are considering the variable x, that x value is changing from 0 to 1 if we are moving from the row 1 to row 2. That is, the value of x is 0 in the row 1 and value of x is 1 in the row 2. Thus, this value cannot be considered into the final reduced set. So the x value can be ignored in this case. And if we are considering the yz value, since this pair lies in the third column, the value of y and z is unchanged and the value is equal to 1, 1. That is, the value of y is 1 and value of z is 1. In the case of a POS, if we are dealing with a value 1, then we should consider the complement of that variable. That is, y is equal to 1 means y complement and z equal to 1 means z complement. Since we are dealing with a POS expression, the reduced pair is represented or written as y dash plus z dash. If we are dealing with an SOP, we should write it as y into z, but in the case of POS, the first pair is y dash plus z dash. If we are dealing with the second pair, the pair marked in the red color, the second pair is having the values x is equal to 1. Since this pair lies in the second row, that is the row number 2, with x value is equal to 1, and this pair lies in the column 3 and column 4. In column 3, the value of y equal to 1 and value of y equal to 1 in column 4, but in the case of z, the value of z is 1 in column number 3, but the value of z is 0 in the column number 4. Hence, the value of z is changing. We should not consider the value of z into the final reduction. That is, the final reduced set should contain only the values which are unchanging. Thus, we should consider only x and y. Here, in both the cases, the values of x and y remains constant with value 1. Thus, in the second pair, the reduced set is x dash plus y dash. Here, x dash comes because the value of x is equal to 1, and also y dash comes because the value of y is 1 in both these cells, and plus symbol represents we are dealing with a POS max term. And if we are considering the unpaired or unreduced set, that is the cell 0 M0, here the value of x is equal to 0 and value of y equal to 0 and value of z is equal to 0 in that particular cell. Thus, we should take that value itself, and representation of that max term is equal to x plus y plus z. So the final POS for this K-map is ANDing all these three individual terms, and thus POS is equal to y dash plus z dash into x dash plus y dash into x plus y plus z. So my dear students, this is how we are reducing a 3-variable Boolean function using a K-map. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, simplify the Boolean function f of abc is equal to pi of 0, 1, 3, 5, 6, 7 using a 3-variable K-map. So dear students, in the upcoming lecture, we are discussing another example for a 3-variable K-map solution. So dear students, see you soon. Until then, goodbye. Thank you and all the best.